Given f of x equals absolute value of x minus 4, on the same grid, sketch y equals f of x and y equals 1 over f of x. So I'm just going to make the table of values for f of x first. So when x is negative 6, absolute value of negative 6 is 6, minus 4 is 2. Absolute value of negative 5 is 5, minus 4 is 1. Absolute value of negative 4 is 4, minus 4 is 0. And I'll let you continue on and just fill the rest of that out. Okay, so in the same way, I'm going to make a table of values for y equals 1 over f of x, which is 1 over the absolute value of x minus 4. So I'm going to start by substituting negative 6 in. So the absolute value of negative 6 is 6, minus 4 is 2, so it's 1 over 2. Absolute value of negative 5 is 5, minus 4 is 1, so it's 1 over 1. Absolute value of negative 4 is 4, minus 4 is 0, so it's 1 over 0, but you can't divide by 0. So this is not defined, and we'll have to figure out what that is later. Absolute value of negative 3 is 3, minus 4 is negative 1. 1 divided by negative 1 is negative 1. Absolute value of negative 2 is 2, minus 4 is negative 2. 1 over negative 2 is negative a half, and etc., etc. And once we have this chart done, we'll talk about it some more. So just keep getting this filled out. All right, once we have all these values, now we gotta graph this. What's gonna be tricky, so everything are nice points, like negative 6, 2, negative 6, a half. I can figure out where those are, but we don't quite know what to do with this negative 4 undefined and this positive 4 not defined or undefined. So those two we got to figure out what to do. And then the other thing that I notice is that the x values don't change. When I look at the point negative 6, 2, its image point is negative 6, a half. Well, it's only the y value that's flipped over. It's only the y value that's the reciprocal. Let's look down at negative 2 becomes negative 2, negative a half. Again, it's just the y value that gets flipped. So first I'm just going to graph the points for y equals f of x, and there they are. And now I'm just going to draw in the lines. So you can kind of see that pattern pretty easily. And same thing, I'll start from the vertex and kind of graph it to the left. And there is the graph of the absolute value of x minus 4. Okay, now I'm going to do my best to graph the reciprocal. So first point's at negative 6, a half. And then negative 5, positive 1, that's a special point. It's actually called an invariant point. And it's the same thing, negative 3, negative 1 is another invariant point. So they are called invariant points because they don't change. So this has 4 invariant points. So one of them is at negative 5, 1, negative 3, negative 1, 3, negative 1, and 5, 1 are all invariant points. Okay, now we're at the negative 4 not defined value, so I'm going to just skip that, plot these points, and then at 4, where the next not defined is, I'm also going to skip that. So I'm just going to kind of leave those alone, and we'll try to figure out what's going on. So there I've kind of graphed that last invariant point at 5, 1, and then 6, a half, and now I'm going to try to find some more points. And I can find more points by basically flipping the y values. So the point 7, 3, the image point for that one is 7, 1/3, because it's just the y value that flips. 8, 4 is going to be 8, 1/4. 9, 5 is going to be 9, 1/5. 10, 1/6. 11, 1/7. All of these are getting smaller and smaller and smaller, but it's really hard to draw that. But as the y values are getting bigger and bigger and bigger, the y values of the reciprocal are going to get smaller and smaller. And this is a really common trait of reciprocals. They always do the opposite of the original function. So if one gets bigger or one's going up, the reciprocal goes down. If f of x is getting smaller, the reciprocal gets bigger. So it always goes opposite. And that's going to kind of help us to see what's going on at 4 and negative 4 as well. Okay, now we've graphed the right side. Let's graph the left before we start dealing with the middle. So basically, the y values are 3, 4, 5 on f of x as we go to the left. So the reciprocal are going to be 1/3, 1/4, 1/5, 1/6. Again, they're getting smaller and smaller and smaller, but they're never going to be negative. So they'll never cross the x-axis. They'll also never equal 0 if you think about it. So because it's going up, it's going to be positive, so that's why it's got to stay above the x-axis. And then say it's 10, well that's 1/10, 100, 1/100, 1,000, 1/1,000. It's gonna be super small, but it'll never equal 0. Because it's never going to equal 0, this makes the x-axis what's called a horizontal asymptote. It's a line that acts as a guide. So the graph of the reciprocal always follows the asymptotes. So the x-axis is always an asymptote for every single reciprocal. So as you go to the right, as you go to the left, the graph always follows this asymptote. All right, now we got to start trying to figure out what happens with those not defined. So I'm going to look at this point, negative 4.5, about a half, and I think that's a pretty good estimate that it's a half. If I do the reciprocal of that, negative 4.5, the reciprocal of a half is 2, so it actually jumps up. So where this is getting smaller as I go from the y value 1 to a half, it's actually getting bigger on the reciprocal. It goes from 1 to 2. And then the same thing just keeps on happening. As we keep on picking smaller and smaller y values, this gets bigger and bigger and bigger, and it's going to get bigger really quickly. Now, it can't equal 0, so I'm not going to make sure that I never touch that line x equals 4. Same thing on the left, I did the same thing. As the y values, if I'm looking at the point 4, 5, 1, and then I look at 4.5, about a half, well that becomes 4.52, so it shoots up really, really fast. Same thing underneath, except for their negative values, so it gets smaller really, really quickly. So it goes down super fast on either side of negative 4 and positive 4. So negative 4 and positive 4 are what are called vertical asymptotes. So wherever something is not defined on a reciprocal, you get a vertical asymptote. And a vertical asymptote, again, it's like a guide. It helps you draw it. The line follows it. You're actually never going to touch on a reciprocal. You'll never touch a vertical asymptote or a horizontal asymptote. So this one's got 2. One at x equals negative 4 and one at x equals 4. And it's got a horizontal asymptote, y equals 0, which is the x-axis. So 2 vertical asymptotes and 1 horizontal asymptote.